This man has a vision to create the best electric cars ever seen and consign gasoline to history.
This is something truly revolutionary.
He wants to build his unprecedented Tesla car in a futuristic new factory and trigger an electric transport revolution.
It's been a long time since something like that happened in the car business, but it's here.
It's a dream many have had, but none have realized. Aluminium bodywork, 19-inch alloys, and a $50,000 price tag. At first glance, this car is the latest in a long line of high-end sedans. But that is where the similarities end. The Model S is a totally different type of car. Tesla believe it can lead a revolution and change the face of motoring forever. It's the first ever mass-made premium sedan powered purely by electricity. Designed to have speed and range, and not a drop of gas.
Our goal is to create an electric car that is the best car in the world and show that that's what an electric car can be.
Tesla's goal is to kill off the combustion engine and prove the electric car has finally come of age.
Driving a gasoline car is going to feel like yesterday. Driving this car is driving the future.
This is Elon Musk, Tesla's co-founder and CEO. Elon is an inventor and a maverick entrepreneur, one of America's youngest billionaires.
I like exploring, I like technology, I like creating things that have never been seen before or even imagined before.
He is a genuine Silicon Valley success story. In the mid-1990s, Elon set up a small internet company. By 2002, he'd sold PayPal for $1.5 billion. Next, he founded private rocket company SpaceX. It's all part of Elon's life mission.
When I was in college, I tried to think about, well, what are the areas that would most affect the future of humanity? So the three things were the internet, making life multiplanetary, and the third being sustainable energy. So that's what really ties together my companies, is that sort of thought from 20 years ago.
Tesla Motors is Elon's sustainable energy brainchild. Named after electric power pioneer Nikola Tesla, it's a car company that only makes totally electric vehicles. No hybrid and no alternative fuels. Absolutely no tailpipe. The company estimates their electric cars cause 50% less CO2, even if much of the electricity comes from a coal-powered plant. It's technology Elon and co-founder J.B. Straubel believe we need.
We're solving problems for our children, our grandchildren. Oil is a finite resource, and eventually we have to find alternatives.
When you take that oil out of the ground and you burn it, it's extremely dangerous. We should not play Russian roulette with the atmosphere. We only got one.
Tesla's founders have a vision of a world without gasoline cars. They are convinced electric is not only cleaner, but better. Now, they want to prove it to the world. They believe their cars can trigger a transport revolution and bring electric motoring to the masses.
What we're doing here at Tesla can have an amazing impact and revolutionize the auto industry and make every car on the road electric. That's our end goal.
The Model S is to lead their revolution. It's to be an electric car unlike any other. A family sedan that can go from 0 to 100 in under 6 seconds, and further on a single charge than any other electric production car. Designed to match the top gasoline competitors.
With the Model S, we're taking things to the next level. It's a full-size sedan, so it's competing in the premium segment, along with, say, a BMW or an Aston Martin.
But the car is only the beginning. Such a revolutionary vehicle demands a revolutionary factory. Tesla needs to create an unprecedented state-of-the-art facility from scratch. Elon brings in Gilbert Passin as head of manufacturing. Gilbert is an expert from one of Toyota's award-winning plants in Canada.
His description of my job to me was very simple. You know, you've got to create the best factory in the world with the best people in the world and make the best premium car sedan. And I said, okay, so where's the factory? Well, you have to find one. Where's the team? Well, you have to make one.
The company purchased a former GM and Toyota site in Fremont, California, on the edge of Silicon Valley. The abandoned facility is a traditional car factory. Dark, little natural light, bare concrete floors. When Tesla Motors move in, it's the birth of a mega factory like no other. It's a totally fresh approach to car manufacture. The walls and floors are painted white. The machinery are striking red. Skylights and windows flood the factory with sunlight.
If you make the factory pristine and clean, that sets the tone for the vehicle. We want that same sense of quality and precision in the car itself.
As part of the whole company ethos, bikes are provided so the workers can get around the factory.
I think it's important to have an environment where people look forward to coming to work. So it's worth putting some effort into making the factory beautiful.
In true Silicon Valley style, they fill the space with the most advanced technology, creating an automated production line capable of building tens of thousands of cars. Super efficient multitasking robots, self-guided smart carts, and computerized production schedulers. The factory is designed to be up there with the very best in the world.
We love engineering. We love beautiful machines. We love new technology. We love to innovate with high technology. And also in manufacturing, we love to do that.
Without training, these sophisticated robots are useless. They all need to be taught before they can run tasks automatically. Every robot is programmed by hand. The Tesla team has meticulously trained 130 sophisticated robots over a year and a half. One of the last robots still to be programmed is a multi-point welding robot. It will be used to join the car's underbody.
These are pretty busy robots, so we got to make sure that our tack time is good.
A robot's work is only as good as the man who trains it. Brad Johnson is a welder with over 25 years' experience at the highest level.
Getting this done today, we'll have the teachings all nice and smooth, and then we can start running 100% and full automatic.
That sounds good.
The space in which the robot operates is treated as a three-dimensional grid. The head can be manually guided to any point using a teach pendant.
There's our start point and our weld position.
Brad guides the robot millimeter by millimeter and uploads the coordinates. The robot works out the most efficient route and runs the program.
Looks like the teaching is right on mark, and we have a really good quality weld right here. So we should be able to run full auto with this weld.
When full production begins, Brad's handiwork will be exactly replicated by the robot 100 times a day. Since their inception in 2003, Tesla Motors have been pursuing their electric car revolution with a step-by-step strategy. In an unconventional business move, Elon decreed that Tesla must invest in their reputation first and worry about profit later. Stage 1. Make a small number of high-value cars that prove electric power can be desirable.
The Tesla master plan is very simple. We start off creating an expensive, low-volume car to help break the mold in electric vehicles.
Plan in place, they set to work on their first car, basing it around the British-built Lotus Elise. 5 years later, they released the Tesla Roadster. Quicker off the blocks than an Aston Martin Vantage, the electric sports car astonishes the motoring world. Step 1 complete in the Tesla strategy.
What we showed was that an electric car could be sexy, it could be fast, and it could be long range. And that if you produce such a car, that people would buy it.
But as a $100,000 two-seat sports car, it's a luxury second vehicle to most of its owners. Time for the pivotal Stage 2 in the master plan. A car that costs half as much and sells in much bigger numbers.
A very important step in the Tesla strategy is really going to show that a mainstream electric car can be better than a gasoline car.
The Model S is the second step in Elon Musk's vision of an electric revolution. A premium mass-market sedan designed and built from the ground up by Tesla. At the studio in Los Angeles, they are working to craft that car.
The Model S is really the foundation of Tesla. It's the first true product designed, engineered, built, manufactured by Tesla. And it's really the beginning of what our mission is about.
Franz von Holzhausen is the chief designer. He believes Tesla's design needs to have some conventional appeal.
It's really easy to have a clean slate and go pretty crazy with that. We had to start with something that people could relate to. If they even knew or cared that it was an electric vehicle, they were attracted to it. We've stretched the sedan and made it a little bit more modern, but it's still a sedan. It still has this somewhat traditional cube, and so it's easy to love because of that association.
Although uniform in appearance, the Model S is a unique car. It was conceived as electric. Even the shape is designed to maximize the battery's range.
The body and the waist here is all slim, so there's no excess fat or body mass on this car. And that's another one of those elements that just translates into great efficiency. This car is one of the most aerodynamic sedans on the market.
In an electric car, Conserving the battery power is so important, the designers put huge efforts into reducing the drag. Even the door handles are aerodynamic, receding flush into the body. But it's the interior that is most heavily influenced by the electric powertrain.
The powertrain is incredibly small. You get the same performance out of a motor that's the size of, a watermelon that fits between the rear wheels, and everything else above that is what I call the opportunity space.
The design team started with the motor and flat battery pack and worked upwards. With the motor next to the wheels, there's no need for a drive shaft, so there is no rise under the rear middle seat. There is no fuel tank or transmission. The Model S has free space from the floor upwards.
What you'll see is a vast amount of space. In fact, it's actually so big that we decided that we could actually fit 7 people, and we do that by putting 2 rear-facing child seats in the back here. And you can see where they fit here, and their legs go right down in there. So this is what we call the frunk, and it's really the trunk in the front of the car. And arguably, you can put a whole bunch of stuff in here, even when the back of the car is totally loaded up with people and kids and stuff. And who doesn't need one of these?
Tesla promote these unique features at every opportunity. As a new mark, they're trying to make an impact in a marketplace crowded with established big hitters.
Just looking at the United States, of the 3 other car companies, the youngest is 90 years old. So clearly this is not an industry that has been supportive of newcomers.
The Geneva Motor Show 2012. Another leg in the company's relentless promotional campaign.
We're done selling Roadsters in North America, so this is our product. It's our product, Tesla product, and therefore we need to get it out to start selling.
Industry experts are judging Tesla on the Model S. It's seen as make or break.
Maybe Tesla has a bright future. I think the Model S is very decisive to see if there will be a great future or if there won't be a future at all.
The company have taken the risk of collecting prepaid orders on the car. They've amassed nearly 10,000 advance sales. The financial boost also creates real pressure.
I get harassed quite a bit actually by some people who have reservation. And it's a lot of expectations, very high expectations that we're going to have to meet and exceed, really.
Some prepaid customers have been waiting up to 3 years for their car. In return, they've been promised a delivery deadline.
I do feel an incredibly strong obligation to those that have placed their faith in Tesla and put down deposits. I'll do anything to make sure that their faith is not misplaced.
The delivery deadline for the first cars is now only 2 months away. But the brand new factory hasn't built a production car yet. If the customers are to get their Model S on time, the facility urgently needs to start manufacturing.
The speed at which we have to work here is extremely important to the company's bottom line. This is a kind of timing that is really, really challenging on many, many different accounts.
Tesla need to build 20,000 cars a year. But before mass production can begin, Gilbert and his team must prove the factory is ready. The company is relying on them to get it right.
We have to make sure that car after car, the quality is there, everything is perfect along the way. So we are really gearing up towards a production ramp-up.
Over the next few weeks, the factory will test manufacture a limited number of Model S. If the line doesn't perform with these cars, the company will be forced to miss their deadline. Tesla's electric revolution would be over before it started.
A very, very important moment is the birth of Model S in our Tesla factory. And it's where, you know, the rubber is going to meet the road, so to speak.
The process begins in stamping. To increase the battery's range, the company have decided to build 97% of the Model S with lightweight aluminium. It's an extremely rare feature in a mass production car due to the cost. Every Model S starts as one of these. The roll is loaded into the mechanical cutting machine. Once cut, the panels are passed to the stamping press.
We need to translate flat pieces of aluminum into 3D forms. And how to do this with aluminum stamping with the level of quality that we expect is really, really challenging.
To meet the challenge, they buy the largest available stamping press in North America. It's one of the first pieces of equipment they install. Over 3 stories high, it has to be transported from Detroit on 70 trains and then entirely rebuilt. The immense pressure from the stamp allows them to press the complex body shapes needed for the Model S. It can be mounted with different heads, known as dies, that mold the panels into a wide variety of shapes. Robotic arms feed the 4 stamps. Each stage forces a more detailed 3D shape, producing stacks of floor plates. These lightweight aluminium parts improve the Model S's power-to-weight ratio, which helps increase the performance and range. The 2 things that obsess co-founder and technical chief, J.B. Straubel.
Any ideas on how we can make it better? Performance and range were the 2 big issues that needed to be improved, and that's where we've put most of our focus on the technology and powertrain.
Powertrain manufacture, 2nd floor. This is where they build the heart of the Model S, the motors and battery packs. Tesla know the electric powertrain will define their cars, so they push to advance the technology themselves.
This is an extremely exciting field where inventions continue to happen even faster than they did, in the years previous.
Tesla's solution to improving battery life appears startlingly simple. They use thousands of small lithium-ion cells, similar to laptop batteries. Thanks to these regular batteries, the company say the Model S has achieved a top range of 480 kilometers.
Once you have 250 to 300 miles of range, then you're in a different usage mode. You're in a range that is equivalent to most gasoline cars.
The car can be charged by 100 kilometers every hour from a regular power outlet. Ultimately, Tesla are hoping to install superchargers along major highways that can charge the car to capacity in 45 minutes.
You can charge the car up every night, but you don't need to. You can actually charge it once a week.
The high-performance battery pack is formed with over 7,000 small cells. They're organized into a flat layer with specific groupings of positive and negative. The final layout is the key to the pack's power and range, and Tesla considers it absolutely top secret. The motor unit is also developed in-house. It's essentially an AC induction motor, a concept invented by 19th century scientist and Tesla Motors namesake, Nikola Tesla. He harnessed an electromagnetic field to turn a basic motor. Modern-day Tesla has developed their motor with a highly conductive copper cylinder. When the electromagnetic casing is fed with current, the copper cylinder inside starts to spin. It's nearly 3 times more efficient than a combustion engine. In fact, there are only 3 moving parts. It connects directly to the rear wheels and doesn't need a transmission.
These are the 3 moving parts in the whole Model S powertrain. One of the cool things also with this very simple gearbox is that when we want to go in reverse in the car and back up, all we have to do is spin the motor in the other direction, and the car backs up. We don't need a clutch, we don't need a separate gear for reverse.
The entire drive unit is under 1 meter long, smaller than a golf bag. But it propels the Model S, a family-sized sedan, into the class of performance cars. In fact, this powertrain creates a totally different driving experience. Program Director Jerome Guillem works constantly to refine it. As with the light switch, electric power can be fully applied instantly.
The first thing that's gonna surprise people is how much torque you get so quickly. That response, instant response, you cannot really mess with the throttle too much because if you push on it, then the car will go. Even from a stop, you have a very quick takeoff because basically the torque is instant. So if I stop here and then I start, you will see that we have an acceleration right from the beginning. Any speed, you have that same torque available. So it's very easy to pass a car or to get out of harm's way if needed.
Unlike gasoline cars, which have to change gears, the Model S can accelerate to top speed totally uninterrupted.
When you go to electric, because you can regulate the torque that goes into a vehicle very smoothly and instantly, we don't need any transmission. This is a single gear powertrain.
The Model S battery pack floor means the majority of the weight is close to the road, making it more stable in the corners and improving the handling.
We have a very low center of gravity, something similar like to a Ferrari.
But the real evolution in the way you drive is down to one of the central innovations in electric cars: regenerative braking. Although the Model S has traditional brakes, you don't have to use them. Regen braking can be engaged by simply easing off on the accelerator.
When you want to brake, you just take your foot off the pedal, like I'm doing now, and the car brakes itself. So you don't need to use the mechanical brakes.
When active, the regen system magnetically resists the motor's rotation, slowing the car and harvesting electric current. The energy recovered recharges the battery and extends the range of the car. When you put your foot down again, the electric power returns. Tesla call it one-pedal driving.
It's a little bit different approach of driving, but once you realize that if you take your foot off the pedal, the car slows down, then it's like, whoa, this is great. I can drive using only one pedal.
In the factory, the delivery deadline is now fast approaching. The Model S test production cycle reaches the main assembly area. The car is based around a partially steel underbody. To make it, engineers weld struts and casts into a framework. Brad's newly trained welding robot is about to be tested in full automation. They have trained the robots with prototype parts. Now, with final components coming through successfully from stamping, it's automated production for real. Under observation, it's a tense time for the team. The robots work in a tightly coordinated chain. The second phase hits an issue. It shuts the whole process down. With the deadline looming, Elon Musk is determined to keep Tesla's waiting customers happy. He's organized a Model S test drive event for the people who've placed deposits.
The test rides will go out onto Jack Northrop Boulevard, so you'll get a chance to see that this isn't some, show car that doesn't actually do what it says. It will go fast and with a lot of people in it. And quietly, yeah.
Many have prepaid years ago, and it's their first time inside a drivable Model S. Customer and board member Steve Jurvetson captures his experience on his mobile phone.
Wow, this is insanely cool. It's a surreal scene. It's way cooler than I can imagine. You really decked this out.
Yeah, it's nice.
The first ride has to be documented here.
The event seems a success. Now the company need to make sure the customers get their Model S's as promised. With only weeks to go, welding has hit a glitch in automation. One of the robotic clamps is millimeters out of line. It's a tiny difference, but enough to disrupt the process.
With the way the robots work and how we have such a tight tolerance of 1 millimeter to stay on, sometimes the new parts won't reach a prox, or the clamp won't close all the way.
A major delay will disrupt the whole production schedule and threaten the deadline. They adjust the settings and set the robots in motion again. This time, it goes off without a hitch. To the team's relief, the process can be approved for mass production. The run through the automated line reaches the Model S exterior. The Model S body is made up of 14 different sections. To speed the workflow, Tesla construct each section at separate sub-assemblies. Door sub-assembly. The internal frame is joined to the exterior panel. As the robot's pincers come together, they fire a rivet and join the aluminium sheets. Over to the right, side body sub-assembly. One of the most advanced aspects of Tesla's robots is that each arm can perform a variety of different tasks.
We have to use all the gamut of technology to make the aluminum joint between stamping and welding and riveting and bonding and all these things using robots that are multitasking.
This flexibility is essential for a compact and efficient workflow. A robot can spot weld using a pincer tool and then automatically detach the pincer and pick up a clamp tool. The same arm that joined the panels can now move it to the next station. It's clever, but tricky and needs constant refining.
When you draw something yourself, you take a pencil, you take a eraser with the same hand, right? And then you change the tool, so to speak. Same thing here.
Once assembled, the sections are brought together at body assembly. Here, they're riveted around the welded underbody to form the basic shell of the car. All the sections are lined up alongside the central framing line. Gradually, the automated line builds up the side sections, ready to house the doors. A test batch of 3 cars is complete. Body assembly has demonstrated it can run successfully in full automation. It's a vital milestone in the countdown to mass production. Completely assembled, the aluminium body is now known as body in white. It's ready for some colour. The body in white is loaded onto an overhead train that carries it to the paint area. At this vast facility, the paint centre is in a totally separate building. The Fremont site covers nearly 95 football fields of space. It's so big, the Model S production line only fills 20% of it. For Gilbert Passin, the extra space is the cornerstone of Tesla's grand strategy for an electric revolution.
The Tesla factory is huge. It's about 5 million square feet on 2 levels. Right now, we are only utilizing a small fraction of the space, but most of it, as you can see behind me, is what we call the dark side. It's sort of dark and not utilized yet, even though we have a lot of plans for the future on how to fully utilize this entire building.
These expanses are an integral part of the company's stage-by-stage building plan. They want to fill the space with a production line for a further range of Tesla vehicles. A very high-volume, economy-priced model, the Stage 3 car.
In the future, we intend to expand our range of vehicles, maybe of a smaller size and also more affordable for the market. And this factory is like ideal, and we are going to make this a super mega factory.
Long term, Fremont is meant to produce the low-cost Stage 3 electric car in the millions. It's the final step in Elon Musk's Tesla master plan.
To really have widespread adoption of electric cars, we have our 3rd generation vehicle, which would be a low-price, high-volume vehicle, and that's really what's going to fill out the rest of this humongous factory. I'd love to bring this to 500,000 vehicles a year as soon as we can.
The future of Elon's strategy first depends on the success of the Model S. In production, the time to the delivery deadline is now running low. The aluminium body arrives on the overhead train from Body Center. Paint Center. This is where they make the car look like a premium sedan. It's a state-of-the-art process.
There's a lot of technology that goes into the Tesla car, but the very first thing they'll tell you is what color of Tesla car they bought. That's how important the paint is.
First, a roller coaster ride of treatment baths. Detergent to clean the surface, and then electrocoating. The electrocoat helps attract the paint to the aluminium. The primed car is ready for colour. This vehicle will be sprayed with their trademark tint, what Tesla calls Signature Red.
It's a color that we developed that's different than anybody else's red. It's been developed with glass flake to get the specific type of sparkle that we want to get in that paint.
It's a masterpiece of perfectly choreographed automation. Even the paint robots multitask, using a handle to open and close the doors. Once it's through, the painted body heads up into the ovens to be baked and double glassed. A specialist team spends hours assessing the finish before the car is passed.
Elon's made it very, very clear to us what his expectation is for the paint job. He wants our paint to look like glass, to look like a piano finish. That's the challenge we've been given, and that's what we're going to do.
The Model S spends over a day and a half in paint. And that attention to detail carries through to general assembly. First, the Model S's panoramic glass roof. The installation robot takes a picture of the top of the car. It uses the digital picture to measure the exact orientation and bond the glass. Next, the interior. The wiring and seats are fitted. The aerodynamic door handles are installed. To get the delicate installation right, a wireless system adjusts the torque for each bolt. The cutting-edge dashboard is lowered into the car. It's proof the car is a product of the tech-savvy US West Coast. The Model S carries a touchscreen tablet inspired by Tesla's Silicon Valley neighbors.
Tesla is very much a Silicon Valley company that has a Silicon Valley operating system, which is similar to a Google or Facebook or Apple, joined together with a tremendous amount of great automotive expertise.
It's about bringing the things that we're used to, our phones, our computers, and the interaction that we have with them into the car.
The car has a mobile 3G internet connection. The driver can download software upgrades and customize the display.
The car's always connected to the internet, so we can understand your daybook, and we can know that you're going to work at 8 a.m. on Monday, and the car can be warmed up for that experience.
The entire command center is housed on the 17-inch tablet. The interior is virtually buttonless.
It does some really amazing things. Not only does it make the rest of the interior super clean and really uncluttered, it allows you to have just amazing control of the car, and it's just, you know, a push of a button. Like magic.
at the factory. The start date for mass production is now only 2 weeks away. The first batch of test vehicles reaches the vital final stages: powertrain and body marriage. In gasoline cars, installing the drivetrain is a lengthy process. With electric, it can happen in just 2 steps. Step 1. The motor unit, complete with suspension and brakes, is bolted into the rear wheel berths. There is no drive shaft or transmission to be attached. In one motion, it's fitted. For final assembly, the work is mainly manual. Like the robots, the line workers' performance is being monitored.
509, guys.
With every vehicle, they're ramping up to the full production cycle time, or TAC time.
Every station here in the factory has to achieve a certain operation in that TAC time in order to get it to our customer on time.
Here, the target is 4 minutes and 40 seconds.
Throughout the build, every single time you may hear me in the background saying, we're at 2 minutes, we're at 5 minutes, right? So they can know exactly where they are when we're shooting to get to that 4 minutes and 42 seconds.
Step 2, battery pack installation. The pack's steel case acts as the car's chassis. Bolted into place, it gives the Model S its rigidity. A stage along, the first complete cars arrive at final inspection. At Elon's insistence, inspection happens on a bamboo platform. He believes you can only judge a car's beauty if it's framed by beautiful surroundings. The last check is the test drive. At Tesla, the track is very different. Because electric cars produce no exhaust fumes, they can be driven indoors.
Our people have done so well at putting this car together. You can see the remarkable quality of the paint and the entire vehicle, the body fit and everything. I'm so proud today.
This is the first Model S to pass through the production test run. And its quality proves the new megafactory is ready for mass production. It's a big moment for the company.
Just to see this car going around the test track here, it really demonstrates the fact that the Tesla factory is ready to go. I just have to make 20,000 per year more of this kind, and it's sort of a, a done deal. We just have to, get it done.
The factory can now push towards the delivery deadline, allowing Tesla to pursue their strategy for an electric car revolution.
Can you imagine if all the cars in the world were able to have zero emission, zero noise, and we could do that in a perfectly clean environment? That would be so cool.
This is Tesla's vision of an all-electric future. No fumes or heat. No noise or dirt. No expensive gasoline. Just clean and quiet streets.
It's truly impressive to see how we are really day by day and person by person changing people's thinking about what electric vehicles are versus what we've all grown up and taken for granted. If we can do that through one product, that's unbelievable.
10 years from now, Tesla will change the perception of what mainstream cars can be. And it'll become clear that electric cars truly are the future.
The Tesla Megafactory may have just built its place in history.